Here's something obvious. The world has to phase out fossil fuels to have a chance of avoiding climate catastrophe. We all know this. But it doesn't seem like the plan for some people.
I think it was Occidental Petroleum last year put out a press release claiming they had produced the world's first zero-carbon barrel of oil.
That's Amy Westerveld, a journalist investigating what fossil fuel companies are up to. And yeah, you heard right, a zero-carbon barrel of carbon. This approach to tackling climate change isn't really about phasing out fossil fuels, because we're going to keep burning more and more. But it's not just fossil fuel companies. Many governments, in promising to tackle climate change, have set net zero targets. And again, you might have thought that this would pretty much just be about phasing out fossil fuels. But you'd be wrong.
Even in 2050, when we are at net zero, it is forecast that around a quarter of our energy needs will still come from oil and gas.
And it gets weirder. Recently, a former head of the Intergovernmental Panel on Climate Change, the IPCC, whose reports helped establish net zero as the central concept in climate policy, well, he called net zero a dangerous trap.
The political trap is it lulls us into a sense of complacency.
Now let's take a minute to understand what's going on. Think of a bucket. It's how the atmosphere works. Every country has a tap that gushes planet heating emissions. It's the cumulative amount that matters for climate change. So now imagine a set of lines drawn around the inside of the bucket. Deepest is the 1.5 line. When the cumulative emissions reach it, a 1.5 degree global temperature rise soon follows. Decades of climate science has helped us identify roughly where those lines are marked. But there are others we can't identify accurately, like the level that triggers the breakdown of the Atlantic overturning circulation, that crucial central heating system we heard about in the last episode, the collapse of which would cause a global food disaster. So rapidly turning off the taps is critical to limiting this danger. Luckily, a helpful design feature is provided by nature, which absorbs emissions through plants, soils, and the oceans, like an outlet valve draining the bucket. So if the taps were turned down, the bucket could reach a balance between what's coming in and what's going out. This balance is where the idea of net zero comes from. The net effect is that the level in the bucket wouldn't increase. But because the amount drained by nature is so small, to reach net zero requires the world to almost completely turn off the taps, to reduce planet heating pollution right down. But that's not how many governments and companies seem to be thinking about it.
Energy giants Shell and Total have announced yet another quarter of record-breaking profits.
BP has slashed planned investment in renewable energy.
Drill, baby, drill.
But how can that add up? How could the world reach net zero and still be burning lots of fossil fuels, filling up the bucket? The answer exposes one huge assumption now underpinning all climate plans: a get-out-of-jail card that many are relying on to make their net zero plans work.
Zero-carbon barrel of oil.
It's an idea that barely anyone's talking about, that we didn't vote for, an idea that might not even work. Because with little fanfare, governments and companies are effectively betting the future on inventing technologies that drain the atmospheric bucket. That's a big bet, and one that helped get us into this mess in the first place. I'm Laurie Laybourn, you're listening to Overshoot, and this is episode 2, Carbon Suckers. It all started in Swedish paper mills. Back in the year 2000, an engineer called Kenneth Mullersten was starting a PhD in Sweden. Now, since then, Kenneth's had a glittering career, and it began with an idea.
We decided that the topic of my dissertation should be on what can be done in Swedish pulp and paper mills to mitigate greenhouse gases.
Kenneth realised there was something special about paper mills. It's all to do with trees. The mills used trees that were specially grown in forests for paper production. They wouldn't have been grown otherwise. And before they were cut down, the trees spent a lifetime sucking carbon from the atmosphere. So, before the trees were fed into the paper mills, they'd help drain a little bit from the atmospheric bucket. That was one benefit. The mills also burn the leftover waste from the pulped trees to produce electricity. That contributed emissions to the bucket, but Kenneth figured they could be captured before this happened by a device in the smokestack that stopped the pollution from coming out. The captured carbon could then be stored underground. There was growing interest in these devices at the time, and installing one would mean that no new emissions would enter the bucket. So, no emissions from the mill, and the trees had sucked some emissions out. Putting that all together, Kenneth realised that the overall contribution of the mills to the atmospheric bucket could be negative.
In that way, you have created a negative emission. So a stream of CO2 that goes from the atmosphere and into the underground.
No one was really talking about negative emissions at the time, about actively draining the bucket beyond what nature already provided. Instead, all the attention was on turning off the taps. And it was Swedish paper mills that led Kenneth to this idea. By early 2001, he was ready to present it to the world.
I went to Cambridge to present this paper at a conference. After I had done my presentation, this gentleman came up to me and looked excited.
That was Michael Obersteiner, a fellow researcher. While governments were taking climate change more seriously, Michael was worried about a future in which it proved to be more dangerous, like if it became clear that the Atlantic circulation was at risk of collapse. He was looking for
the backup option or a risk mitigation option. We could, in kind of a Manhattan action, a Manhattan project type, deploy negative emissions on a large scale and avoid such abrupt climate changes.
That's Michael. And he thought Kenneth had found the backup plan, because Michael saw this was bigger than Swedish paper mills. Kenneth's idea could be extrapolated to the global scale. Together, they came up with a plan. Large forests could be grown that suck carbon from the atmosphere, helping empty the bucket. The wood could then be burned to make electricity. This would happen in power plants fitted with carbon capture devices, so no new emissions were added to the bucket. Overall, it didn't just mean zero carbon emissions from electricity. It meant negative emissions on a global scale, so lowering the level in the bucket. It quickly came to be known as bioenergy with carbon capture and storage, or BECCS, BECCS for short. And yeah, it's a clunky name, but it stuck. Yet throughout, Kenneth and Michael were clear.
You never want to have this competition between BECCS and decarbonization or defossilization. So it can only be complementary for managing additional risks. So basically you restrict yourself to a decarbonization pathway, and if you get bad news, you switch it on.
This wasn't a backup plan for if countries had collectively failed to turn down their taps. It would be impossible to deploy carbon capture devices and grow forests at the scale and pace needed to handle that situation. If there wasn't enough decarbonization going on alongside it, the backup plan wouldn't work.
This option should not be seen as an argument in favor of doing nothing about the climate change problem now and then switching on this technology if climate change turns out to be a significant problem. It's not likely that BECCS can be initiated sufficiently rapidly at a sufficient scale to follow this path.
While others had been playing around with the idea, it was Kenneth and Michael who first published it in a major academic journal, along with some colleagues. And soon, lots of people noticed. Among them were a bunch of scientists. They were building computer models of how to decarbonize the global energy system, and they were struggling with a problem. The models showed them that limiting climate change to well below 2 degrees would require massive changes to society, costly or disruptive changes, like large reductions in the amount of energy used by wealthy countries and changes in lifestyles, changes that might not be politically palatable. And that led some modelers to think of Kenneth and Michael's backup plan. They used the models to look at scenarios of the future in which there was large-scale bucket draining. It helped resolve a tension between, on one hand, the need for huge changes in how energy was used and how societies were run in order to tackle climate change, and on the other hand, a world demanding ever greater quantities of energy and fossil fuels. But the modelers reiterated Kenneth and Michael's warning that there were huge questions about what bucket draining could be achieved in reality. But all this was often missed. with assumptions buried deep in technical reports that were presented to decision makers who often didn't understand the complexities. And then two things happened. First, countries weren't reducing their emissions fast enough. In fact, some were doing the opposite, opening their taps. So the bucket was filling faster than ever. Second, growing evidence showed that a global temperature rise above 1.5 was more dangerous than originally thought. That's the story we heard in the last episode.
We weren't hearing 2 degrees to get by. It was 1.5 to stay alive.
So not only was the bucket getting fuller, but the line to stop at was now lower. And so the modelers assumed more bucket draining to make the numbers work. Here's Michael again.
Then there was the race who produces the deeper scenarios.
But the more this happened, the less attention was being paid to how it was a big assumption to think large-scale negative emissions could be relied on in the future. And so bit by bit, the gap between how people spoke about net zero and how the world was actually supposed to get there grew wider and wider. And by 2018, it became clear there was no longer a choice. When the IPCC published its report on 1.5 degrees that year, nearly all the scenarios for meeting the goal relied on large-scale bucket draining in the future. And then more recently, as it's become clear that the world is heading over 1.5, the assumptions have gone into overdrive. It's the only way that a contradiction can be reconciled. On one hand, countries and companies are burning vast amounts of fossil fuels and the world is overshooting 1.5 degrees. But on the other hand, these same governments and companies say they're committed to staying below 1.5. How can that add up? The answer: more bucket draining. But this requires more assumptions about what happens in the future. Here's Kenneth again.
I have heard many scientists saying that, we didn't think that what we were doing was realistic, but we were asked to do it. So they're presenting scenarios that are compatible with 1.5 degrees, and they include incredible, massive amounts of negative emissions that we really do not know, how do we get all this into the world?
And the biggest problem of all is that the promise of draining the bucket in the future might have obscured the failure of governments and companies to turn down the taps in the present. If you think the bucket can be drained later, you might pay less attention to how it's filling up right now, to the failure to rapidly turn off the taps. And if you're a politician, say, who's been pressured to set a net zero target, you know that reaching it could be hugely disruptive to the status quo. So if someone tells you that you can go slower on emissions today, but still hit net zero in the future, then that sounds great. Or you might not even notice, or simply fail to understand the complexity, and instead just interpret the information you receive as meaning reaching climate goals is possible within what you see as politically palatable. So the promise of carbon sucking gives a seductive excuse to carry on. It gives the impression there's an easier way to get to net zero. And that's why Sir Bob Watson, the former head of the IPCC who I mentioned earlier, has called net zero a trap.
The political trap is it lulls us into a sense of complacency. Any politician can guarantee we'll have net zero by 2050. They're not going to be around to hold them accountable. It's taken our eye off the ball, and the ball is near-term reductions, 50% by 2030.
But this complacency doesn't just result from the well-meaning actions of experts responding to their perception of what's politically palatable, nor the misunderstanding and misguided actions of non-experts. To explain, here's Ketan Joshi, an expert in how companies think about negative emissions.
The IPCC say carbon removal is not a replacement for reducing emissions. The funny thing is that it is, in the sense that the way it's talked about in the corporate world, which I have spent plenty of time examining and understanding and talking to folks who write sustainability reports and doing things like that. They talk about carbon removal very much as a way of undoing their emissions. Almost exclusively, they present it as a tool for dealing with what they've done.
For a fossil fuel company, turning off its tap can mean reducing profits. But the promise of draining the bucket offers an excuse to carry on. And so it's been used by these companies to cultivate the impression there's an easy way out, sowing confusion and complacency, part of a vast mechanism of reassurance employed to delay rapid decarbonisation. Just think of that zero carbon barrel of oil. To justify this claim, the company points to its carbon capture projects and also says it plans to suck carbon from the atmosphere at some point in the future and to store it indefinitely. Here's Amy Westervelt again.
You know, it's not a hard sell to tell people, don't worry, nothing has to change. We can just slap some technology on it.
So bit by bit, the world has become reliant on sucking vast amounts of carbon from the atmosphere. Whether they realise it or not, whether you realise it or not, this is what the world's governments have committed us to. In less than 2 decades, an idea to help Swedish paper mills reduce their emissions has gone global, becoming an integral part of the world's response to climate change. Kenneth and Michael's backup plan became the plan. So what scale of bucket draining are we now talking about? Now, there's no straight answer, partly because it depends a lot on what the world does over the coming years. If it continues to leave the taps wide open, then more carbon sucking will have to be done. But playing around with different scenarios, modelers have come up with some answers. You can find them in a report called the State of Carbon Dioxide Removal, or the State of CDR for short. The report looks at a scenario with limited overshoot of 1.5. That's one in which the world hits 1.6 for a few decades and then falls back below 1.5 by the end of the century, after the atmospheric bucket has been drained below the 1.5 line. That's the safest scenario, one that runs the least risk of triggering disastrous climate impacts. And in that scenario, the report anticipates that worldwide bucket draining efforts will have to more than triple in the next decade and increase nearly 6-fold by 2050. That's going from removing about 2 billion tonnes of carbon a year now up to about 7 billion a year by 2035. That's a planetary scale engineering challenge, another one alongside the project of phasing out fossil fuels. At the moment, almost all the bucket draining, 99.9%, is done by working with nature, helping open its outlet valve. David Ho can explain. He's a professor of oceanography at the University of Hawaii.
There are what people call nature-based solutions, which are, say, afforestation, reforestation, or doing something with soil carbon, or restoring wetlands.
The remaining 0.1% comes from techniques that aren't primarily about supporting nature. Instead, these are
technological solutions. Like one that's very popular these days is direct air capture, which is, imagine giant fans sucking in air and then some sort of sorbent that removes the CO2 from the atmosphere, and then you would then store the carbon somewhere.
We could think of this as the equivalent of creating a new outlet valve. And so far, it's a tiny one.
Let's say a particular direct air capture plant will remove 4,000 tons of CO2. If we look at the direct air capture plant as a time machine that takes us back to an atmosphere we had in the past, it's an atmosphere that we had 3 seconds ago. So less than the time that it took me to complete this sentence. And it would take a year to take us back 3 seconds. And in the meantime, we've moved forward by an entire year. So 4,000 tons of removal right now, it's very ineffectual.
But according to the State of CDR report, that will have to change. These technologies will have to mature very quickly. By 2035, the carbon sucking and storing done by these technologies will have to increase more than 1,000-fold. And by 2050, it must increase by nearly 4,000 times. And then it must sustain the carbon sucking and storing for generations. Can the world do this? It's not impossible. Humanity has pulled off extraordinary feats before. But there are some huge challenges to be navigated. Firstly, it's unfair. Here's Michael Obersteiner again.
Not only do we transfer huge risks to future generations in terms of climate impacts, but we also burden them with this environmental guilt to take out CO2 out of the atmosphere, which we don't really know today how to do this on a large scale.
Barely anyone realises this, let alone has had a say. It rarely gets reported in the press. It doesn't feature in any political manifesto. No one voted for it. Many people did vote for net zero, but presumably did so thinking it meant reducing emissions, not being signed up for another planetary scale engineering project on the side. So what happens, politically, when people start to notice this? Is it legal? Who is supposed to do it? Who will pay for these removals? How will they be held accountable? For example, is a country like Uganda expected to contribute? Uganda is responsible for about 0.007% of the total carbon in the atmospheric bucket. Compare this to the US, which has contributed 3,570 times more. Uganda is already struggling to handle increasingly deadly climate impacts. Is it now expected to help invent and roll out vast carbon-sucking capabilities as well? These are huge and as yet unanswered questions. Another problem is that even if all this carbon-sucking were possible, it comes with risks and trade-offs. Here's Professor Diana Urga-Vorsatz, a scientist at the Central European University in Vienna and also a vice-chair of the IPCC, talking here about the impacts of expanding natural carbon removals.
Just to capture 3 gigatons, we are talking about as much land required as 2 times India, the total land of India. We are talking about so much water requirements potentially as twice the present water use for agriculture.
And who decides how to use the land? Here's Ketan Joshi again.
What you often end up with is situations where corporations will seize land or they'll take control of it, often with damage to indigenous communities.
To make matters worse, all carbon that's taken from the atmosphere must be stored indefinitely, generation after generation, whether it's captured by machines and locked underground in geological formations, or captured and stored by nature, like in vast forests. It can't get back into the bucket. But what happens if that forest burns down?
If that forest burns down, what if we do decide to convert that land again to parking lot or for a port or anything else we need?
And the draining and storing is expensive, at least in the current prices for these technologies. Michael Uberstein has crunched the numbers on how expensive it could get if countries who've contributed most to the bucket were to clean up their own mess.
This basically eats up their entire governmental budget.
And these technologies currently use huge amounts of energy.
You end up with carbon removal facilities incentivizing growth in fossil fuel power output because there's new demand growth on power grids. Alternatively, you could end up with new carbon removal technologies consuming electrical power from renewable energy that should be displacing those fossil fuels.
But let's stop there. You get the picture. And it's important to understand 3 things about that picture. Firstly, the challenges we've heard must be overcome. The inescapable reality is that the world needs to develop capabilities for large-scale bucket draining and carbon storing. That is, if we want a livable climate. And that's the reality of overshooting 1.5 degrees. Think back to the story of the storm and the ship from the last episode. The world is now in the storm, and it needs all the tools at its disposal to steer away from the biggest risks. Whether we like it or not, for climate change, carbon removals are now one of those tools. And there are upsides to this reality, like how expanding nature's ability to remove carbon can also restore ecosystems at the same time, helping the world tackle the other vast environmental crises interrelated to climate change. That's a win-win. But that won't be enough. That brings us to the second point. Here's Kenneth Mullersten again.
I don't think negative emissions is the problem. The problem is that we are not decarbonizing. The world has not collaborated in a way that is necessary to deal with climate change. That is the problem.
While large-scale carbon removals are now inevitable, they cannot help us avoid climate catastrophe without a massive acceleration in decarbonisation. The scale of emissions pouring into the atmospheric bucket is simply too great, no matter how heroic the assumptions of future draining become. So the necessity to scale up carbon removals can't be used as an excuse to continue to go slow on reducing emissions. Which means no more promises like zero carbon oil, no more carbon-sucking fantasies, whether these fantasies are the result of good intention or they're a malicious mechanism to justify the status quo and sow complacency. These fantasies must end because they're part of the reason why the world is now in the storm of overshoot, and because they can still distract from navigating it. And one idea to help this happen is to use a different approach to net zero targets. Currently, many don't specify how much of the effort to reach net zero will come from reducing emissions and how much will come from removing them later. And that's caused confusion and complacency. As Bob Watson says, this must change.
I would argue that whether you're a government or the private sector, tell us what those actions are going to be and what are direct emission reductions and what are reliant on negative emissions.
But more than anything, the need for even more carbon removal and the risks and trade-offs that come with it should prompt a deeper rethink of how governments and companies approach decarbonisation, about what's considered politically possible. Often, this is about replacing fossil-burning technologies with zero-carbon alternatives, like swapping petrol and diesel cars for electric. But there's far more to decarbonisation. Here's Diana Urga-Vorsatz again.
The more we allow both our energy and also material use to increase, and also the slower we implement our zero carbon technologies, all three of these increase the amount of carbon dioxide removal that we will have to do.
So decarbonisation can be sped up if the world also slows down the increase in the use of energy and materials, which has been going up year after year. This is a particular responsibility of wealthy countries and communities that use huge amounts of these resources, far beyond what they might really need. But so far, this isn't a major part of their approach to decarbonisation. And it requires something more than just swapping dirty technologies with clean. It means fundamentally redesigning the carbon-spewing bits of society. Buildings can help us understand this. Solar panels and zero-carbon heating options can reduce their emissions. But so can using design techniques that passively manage temperatures and so need less heating or cooling in the first place. Like using more insulation in cold climates, or having designs that shade and move air to reduce heat in hot climates. Buildings like this have been built for millennia, all over the world. In many ways, this is boring, at least compared to electric vehicles or carbon-sucking machines. But often it's the boring things that we've known about for a long time that can help reduce emissions fastest. And these things can also improve people's lives at the same time.
We need extremely little energy for heating or cooling that building, while actually the residents becoming even healthier and having much better air quality and also much better comfort, feeling of thermal comfort. And that we can do it in really cost-effective ways.
That's a win-win, and there are many more of them. Take planned obsolescence, the technique used by companies that means your washing machine or phone needs replacing every few years. Stamping down on this, demanding that companies make more durable products, will reduce the use of energy and materials and save us money. And in doing so, they will also help us limit the growing challenge of bucket draining. Some people go further and advocate that high energy activities should just be banned, like the use of private jets. Or even further still, to say that the consumerism at the heart of many wealthy societies must be dialed back. Whatever it is, the key is to compare ideas for reducing energy use with the alternative, which is an even bigger bucket draining challenge in the near future, with all the huge risks, trade-offs, and unfairness that comes with it. That's a central reality of Overshoot. But not enough governments and companies are exploring creative ideas for how to do this and how to make them politically possible. Sure, it might not be easy, but it's far more realistic than becoming a bunch of carbon suckers. Overshoot was produced by Planet B Productions in partnership with the Strategic Climate Risks Initiative. It was written and presented by me, Laurie Laybourn, with research by Ben Shred-Hewitt, production coordination from Daniel Norman, script consulting from Daniel Trilling, sound design and mix by Ben Heidemann and James Fox, original music by Haniel. And special thanks to Aaron Thierry, Mirta Boot, James Dyke, Henry Throp, Stephen Backhouse, and you. Thank you for listening. Don't miss an episode or our bonus content. Search for Overshoot Pod online.